get into the class. First question, question number 1. If A, B, C are three natural numbers, there are three variables which are given. The domain of the variables is all are natural numbers, and these numbers variables are in arithmetic progression. A, B, C are in arithmetic progression. Arithmetic progression means difference between two consecutive values will be same. So B minus A is equivalent to C minus B. 2B is equivalent to A plus C, where B is also called the arithmetic mean of A and C. A plus B plus C, it is nothing but 21. If A plus B plus C is 21, which is given in the question, and A plus C is given as 2B, which we know it. If I substitute instead of A plus C 2B, 3B equivalent to 21. B is nothing but 7. If B is 7, A plus C value is nothing but 14. A plus C value is 14, and it is given in the question that A, B, C are natural numbers. That means A can take 1, starting with 1. C can take 13. C can take 13. A can take 2. 2 plus 12 is 14, and A can take till 13. 13 plus 1 is 14. So, how many values are there? 1 to 13. Totally, how many values? A, B, C can take 13. B value is anyway fixed. So, 1 is, A is 1, B is 7, C is 13. A is 2, B is 7, C is 12. Another value, right? Again, A is 3, C will be 11, 3 plus 11 is 14, again it is 7. So, it will go on from 1 to 13, answer is 13, right? Very straightforward question, just by looking at a question itself, you should get the answer. Again, I am repeating for the second time explanation. A, B, C are in arithmetic progression. If A, B, C are in arithmetic progression, difference between two consecutive values should be same. B minus A is equivalent to C minus B. So, 2B is equivalent to A plus C. 2B is equivalent to A plus C. I will develop some questions based upon this idea. A plus C is nothing but 2B. 3B is 21. B is 7. If B is 7, A plus C is 14. Because A, B, C are natural numbers, I will get A value 1, C value 13. A value 1, C value 13. And it goes on up to A value 13, C value 1. 1 to 13. 1 to 13, how many values? 13 values. 13 values. Now, in examination, this was the question which was asked. First, I will write the question. From the set of question, from the set of first 20 natural numbers, from the set of first 20 natural numbers, how many triplets, A, B, C, A less than B less than C can be chosen such that they are in arithmetic progression. Please read the question. From the set of first 20 natural numbers, we have to select three variables A, B, C such that A less than B less than C. This condition is given such that they are in arithmetic progression. Listen carefully. Anil Nair's way of solving. How I solved this question. First one, from the set of first 20 natural numbers. So 20 natural numbers is 1, 2, 3, 4, 5 till 20. From this, I have to pick three values such that they are in arithmetic progression. A, B, C are in arithmetic progression. If A, B, C are in arithmetic progression, just now we have seen 2b is equivalent to a plus c. 2b is equivalent to a plus c. Immediately, I don't need to find the values of a, b, c. Immediately, it should strike us 2b, 2 into any number, it is an even number. 2 into any number, it is an even number. So, if it is an even number, this will be even plus even is even, or odd plus odd is also even. Am I right? Even plus even is even, or odd plus odd is also even. Out of 20 natural numbers, how many are even numbers? There are 10 even numbers. Which are 10 even numbers? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. How many odd numbers are there? 10 odd numbers are there. So, he is telling 2b is an even number which is obtained because of even plus even. Out of 10 even numbers, select any 2 even numbers. Out of 10 even numbers, selecting any 2, which is 10c2. R is nothing but plus. Out of 10 odd numbers, selecting any 2 odd numbers. Again, out of 10 odd numbers, selecting any 2. NC2 is nothing but n into n minus 1 by 2. So, this is nothing but 10 into 9 by 2. 45 plus 45. Answer is nothing but 90. No values. Finding out the values of A and C, you don't need it. Why? Because this is an even number. Otherwise, the cases, the time consuming will be very high. A is 1, C is 3, D is even plus even, A1, C3, A2, B4. Like that cases, please don't find it out. 1, 2, 3, 4, 5 till 20. So, there are 20 natural numbers. In 20 natural numbers, there are 10 even numbers and 10 odd numbers. If A, B, C are in arithmetic progression, 2b is equivalent to a plus c. The important catch in the question is 2b. Any number multiplied by 2, it is an even number. Even plus even is an even number. Odd plus odd is also an even number. Out of 10 even numbers, select any 2. Out of 10 odd numbers, select any 2. 10c2 plus 10c2. Answer is nothing but 90. We will do 1 or 2 more examples so that it will be clear. Instead of 20, if it is first 35 natural numbers. Okay, now one doubt a student might get. A less than B less than C. Sir, where it is used? Always remember, if conditions are given in the question, it is nothing but selection. I am selecting based on a condition. A less than B less than C is the condition given in the question. So, it is a selection. That is the reason I used out of 10, select any 2. I did not use NPR only because of this reason. If the conditions are given in the question, then it is selection. It is nothing but NCR, but not NPR. That is exactly why I did not use NPR here. Conditions are given, it is selection. Please try to answer this question orally. A less than B less than C, such that A, B, C are in arithmetic progression. If they are in arithmetic progression, 2b is equivalent to a plus c. 2b, it is an even number. A, it is an even number. Even plus even, or odd plus odd. Two cases will come. First 35 natural numbers. That means it is 1, 2, 3, 4 and so on up to 35. 1, 2, 3, 4, 5 and so on up to 35. The largest even number is 34. 2 ones are 2. 2 2s are 4, 2 17s are 34. So there are 17 even numbers. There are 17 even numbers out of 35. 17 are even. Remaining odd are 18 are odd. 18 are odd. Out of 17 even numbers, select any two. Or condition plus. Out of 18 odd numbers, select any two. So it is 18C2. I hope it is clear, right? NC2, you should know it. The value is n into n minus 1 by 2. n into n minus 1 by 2. 17C2, it is nothing but 17 into 16 by 2. 18C2, value is nothing but 18 into 17 by 2. 18 into 17 by 2. Substitute and get the answer. I hope this idea it is clear, right? Question based upon arithmetic progression. Question based upon arithmetic progression. Now, next one. The digits are 1, 2, 3, 4, 5. The digits are 1, 2, 3, 4, 5. How many 5-digit numbers? Listen carefully, sir. How many 5-digit numbers that can be formed? How many 5-digit numbers that can be formed using the digits? How many 5-digit numbers that can be formed using the digits? Repetition of digits not allowed. Repetition of digits not allowed. Repetition of the digits is not allowed, such that first case, tens place is greater than units place. Tens place is greater than units place. Tens place is less than units place. Tens place is less than units place. Hundreds place is greater than tens place, greater than units place. Hundreds place less than tens place, less than units place. Hundreds place less than tens place, greater than units place. Greater than units place. Please put a star mark on this question, sir. Please put a star mark on this question. Kindly make a note of it, sir. Very, very important type. Very, very important type. How many 5-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, such that repetition of the digits is not allowed, such that tens place greater than units place, tens place less than units place, hundreds place greater than tens place, greater than units place. So 3 more questions are there. First we will see the concept. First I require a 5-digit number, 5 slashes. How many digits are given? 1, 2, 3, 4, 5. 1 to 5, any one out of the 5 will come. Repetition is not allowed. 1 digit is fixed, 4. 2 digits are fixed, 3. 3 digits are fixed, 2. Remaining 1 digit, it is 1. So in this one, 5 factorial, which is 120. What is these 120? 120 is nothing but the total 5-digit numbers. 120, it is nothing but the total 5-digit numbers. 120, it is nothing but the total 5-digit numbers. In that 120 5-digit numbers, which all will satisfy these conditions? 5 different questions are there. Tens place greater than units place, tens place less than units place. Now see here. Listen carefully. First, I will do it in a new slide. So total 5 factorial. 5 factorial is 120. 120, it is nothing but total 5-digit numbers. Total 5-digit numbers. First case, tens place greater than units place. Tens place cannot be equivalent to units place. If it is equivalent to, that means the repetition of the digit C is allowed. But the question is, repetition of the digit C is not allowed. Total 120 numbers are there. There are two place values, units and tens. These two place values can arrange among themselves in two factorial ways. It could be TU, right, tens place greater than units place, or tens place less than units place. This case won't come because repetition of the digits is not allowed. Tens place greater than units case, one case I require. So 1 by 2 factorial into 120, answer is 60. Total 120 numbers are there, out of which the last two places can arrange among themselves. Last two places are units and tens. This can be arranged among themselves in 2 factorial. One case is tens place greater than units place. Suppose if the question is tens place less than units place. Tens place less than units place. Actually, total 120 numbers are there. Two place values can arrange among themselves in 2 factorial. 2 factorial, out of which one case tens place is less than units place. Again, the answer is nothing but 60. Answer is nothing but 60. Think logically. Suppose you got two digits 4 and 5. Let these 4 and 5 be assigned to the last two places. 4, 5, 5, 4. Tens place less than units place, tens place greater than units place. I hope it is clear. Once you understand, it is very, very easy, sir. Hundreds place greater than tens place greater than units place. Forget about these place values. Actually, 120 numbers are there. 120 into. How many places are there? Units place is there, tens place is there, hundreds place is there. Example, suppose last three places it is taking 1, 2, 3. These three digits can arrange among themselves in how many ways? 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. Are you all with me? Three place values can arrange among themselves in 3 factorial, out of which hundreds greater than tens greater than units. How many will satisfy? 1. Answer is nothing but 120 by 6, which is nothing but 20. Which is nothing but 20. Suppose if the question is hundreds place less than tens place less than units place. Actually 120 numbers are there. 120 numbers are there. These three place values can arrange among themselves in 3 factorial. 100 less than 10 less than union. You take this example. Hundreds less than 10 less than union. Again 1. 120 by 6 is nothing but 20. Next case. Hundreds greater than tens less than union. Units place. So 120 into. Hundreds is greater than tens. 2 is greater than 1. 1 is less than 3. 3 is greater than 1, 1 is less than 2. How many are satisfying? 2 by 3 factorial. 2 by 3 factorial, which is nothing but 40. Are you all with me? There is no counting required in any of these problems. This is a beautiful way of first finding out total how many numbers, then finding out in how many ways these place values can be arranged among each other. In how many ways the place values can be arranged among each other. Tens place, remember the repetition of the digits is not allowed. Remember, repetition of the digits is not allowed. Repetition of the digits is not allowed. Repetition of the digits is not allowed. One more question we will solve, then it will be very, very clear to you. Suppose, in how many ways 4 digits numbers can be formed using the digits? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Such that tens place is greater than units place. Tens place is greater than units place. thousands place is greater than hundreds place, greater than tens place, greater than units place, greater than units place. You don't need to worry too much about these calculations. It will come very naturally once you understand the fundamental principle of counting. I require in both the questions, repetition of the digit C is not allowed. Repetition of the digit C is not allowed. If the repetition of the digit C is not allowed, now see here, 5 digits, any one out of the 5 will come, any one out of the 4 will come, any one out of 3 will come, any one out of 2 will come. 5 into 4 into 3 into 2. Total, these are the 4 digit number that can be formed from the digits. Tens place greater than units place. 2 place values can arrange among themselves in 2 factorial. Tens greater than units, 1 case. Tens less than units, 1 case. Finish. Here also it is 5 into 4 into 3 into 2. 4 values can be arranged among themselves in 4 factorial, which is 24. All of them hundreds greater than thousands, 1000 greater than 100 greater than tens greater than units place, only 1 case will be there. So 24. Answer is nothing but 5. 2 cancel. Answer is nothing but 60. Answer is nothing but 60. Everybody kindly reply in the live chat if this concept is clear. In this 1 hour, I will discuss more of concepts and tricks to simplify the counting problems. Everybody kindly reply if it is clear. Slowly, class by class, we will increase the level of competency. We will increase the level of competency. Tomorrow also, please make a note, sir. Class. Everybody, I hope the idea it is clear. So, how many 4 digit numbers can be formed from 5 digits? Total 120. Place values tens and units. 2 place values can be arranged in 2 factorial. 1 case tens place greater than units place. 1 case tens place less than units place. So, all of them greater means only 1 case will be there. 1 case will be there. All the numbers are in ascending order, only one way, right? 5, 7, 8. Only one way there will be in ascending order. Only one way there will be in descending order. Even the answer for this question is also same. So, these also nothing but 1 by 4 factorial. It is nothing but 120. It is nothing but 120. Right? I hope it is clear. Now, 1 minute. Sairam says why it is 24 in the denominator. Here there are 2 place values, Sairam. 2 place values can arrange among themselves in 2 factorial ways. So it is 2 factorial. Here it is thousands place. Here it is hundreds place. Here it is tens place. Here it is units place. Here it is units place. So these nothing but 4 place values can arrange among themselves in 4 factorial. There will be only one way, they will be in ascending order. There will be only one way where there will be in descending order. I hope it is clear. Write in B, 5432 and 4321 is allowed na, sir? 5432 and 43, then it is not 2 ways. Where did I not say that it is 2 ways? What is these 5 into 4 into 3 into 2? It is not the 5 into 4 into 3 into 2 is the total number of 4 digit numbers that are formed using these digits with repetition not allowed. This is not the number 5432. These are the total 4 digit numbers which can be formed. Total 4 digit numbers which can be formed. Right? In case if you want to know the answer, 5432 is one way. Right? Please tell me 5421 is another way. Next one, 5321 is another way. 4321, it is another way. Right? Next one, Total 5 cases we should get. 5431, 5431 where we have taken, 5431 is another way. 5431 is any other way. You cannot take 523 and everything. These are the 5 values. In this one, this case and this case we got. Total 5 cases. This is an enumeration case. Enumeration, we will try to avoid it as much as possible. Right? Each and every question. 6 days. Target is to become an expert in permutation, combination and probability by solving minimum 300 plus variety of questions in the next 6 working days. Modern Max is our target, right? Next one, another one. From the set of first 20 natural numbers, from the set of first 20 natural numbers, how many triplets, A, B, C, A less than B less than C, can be formed such that they are in geometric progression. From the set of first 20 natural numbers, how many triplets can be chosen such that they are in geometric progression? 2 cases we have to do. Case 1, where R is an integer. R is nothing but a common ratio. R is nothing but an integer. R is common ratio. Case number 2, where R is nothing but a rational number. R is nothing but a rational number. Rational number is nothing but integer plus fraction. Integer plus fractions. 2 cases we have to do. We only did for arithmetic progression. Let us do the same case for geometric progression. From the set of first 20 natural numbers, how many triplets can be chosen such that the triplets are in geometric progression? R is an integer, R is a rational number. Case number 1. First it is 20 natural numbers. 1, 2, 3 and so on up to 20. 1, 2, 3 and so on up to 20. I have to choose a triplet A, B, C such that A less than B less than C. They are in geometric progression. If they are in geometric progression, B square equivalent to A into C. B square equivalent to A into C. Idea is B square is a perfect square. B square is a perfect square. What are the perfect squares from 1 to 20? 1 square is a perfect square. 2 square, 4 is a perfect square. 3 square, 9. 4 square, it is nothing but 16. 1, 4, 9 and 16. But B square equivalent to 1. B is nothing but 1. A less than B less than C. A less than 1 means A will get into zeros and everything. It is a natural number set. So, these are not possible. I hope it is clear. So, if B square is nothing but 4, because B is a natural number, B value is 2. If B is 2, A is less than B. So, these is nothing but the only value possible is nothing but 1. Ratio is nothing but 2. Next C value will be 4. 1 to 4. 1 to 4 it is possible and it's a derivative into 2. Into 2 is nothing but 2, 4, 8 it is possible. Into 3 is nothing but 3, 6, 12 it is also possible. Into 4 is nothing but 4, 8, 16. These also possible. Into 5 is nothing but 5, 10, 20. This is also possible. 5, 10, 20. These also possible. So totally how many we got? 1, 2, 3, 4, 5. You don't need to do all this. Take the upper limit value 20. What is the b square value that we have taken? 4. 20 by 4 is nothing but 5. If you get a decimal value, ignore the decimal value. 5 directly we will get. Next perfect square is b square equivalent to 9. If b square is equivalent to 9, b will be 3. Minus 3 not possible, a, b, c are natural numbers. If b is 3, a value is less than b, a can be 1. So 1, 3, common ratio it is 3. So it is 139. Derivatives are 139 into 2, 2, 6, 18, 2, 6, 18, 1 and 2. How many values we got? 2. You don't need to do it. Take the highest value in the set, 20. Perfect square is 9. 20 by 9, 2.2. I told you to eliminate decimal, so it is 2. Next it is b square is 16. B value will be plus 4 or minus 4. 1, 4 and it is 16. No other case is possible. Directly 20 by 16 is nothing but 1. Either b square 4 or 9 or 1 minute, sir. Praveen, ఇది పాడట్లేదు వేరే పేరు. So these is nothing but 1. 5 plus 2 plus 1 is nothing but 8. I hope it is clear. All these b square 4, b2, all these not required. Just divide it directly, you will get the answer. Directly you will get the answer. These methods probably you will not get it in the regular textbook, sir. Please listen carefully. Please listen very, very carefully to every concept. B square equivalent to b square equivalent to so 1, 2, 3 till 20. 1, 2, 3 till 20. What we did? Perfect squares are 20 by 4 is 5, 20 by 9 is 2 and 20 by 16 is nothing but 1. So 5 plus 2 plus 1. Answer is nothing but 8. Now let us see the exam model question, how to solve it orally. 1, 2, 3 till 40. A less than B less than C such that A, B, C are in geometric progression. What will be the answer? First is 40 by 4. B square cannot be 1. B value will be 1. A value less than 1. That is not possible, right, in natural numbers. 40 by 4 is 10. 40 by 9 is 4. 40 by 16 is 2. 40 by 25 it is 1. 40 by 36 it is also nothing but 1. So 14, 16, 17, 18. Total 18 values directly you will get. Please don't show your mathematical intelligence and write down all the possible triplets. I hope you enjoyed this beautiful shortcut of finding out how many total triplets are there without even writing the triplets. Kindly reply if it is clear to you. Everybody, we are discussing a case number 1 where r is an integer. We are discussing a case where r is an integer, not a single class of permutation and combination. In case if you want this topic to be your favorite topic, do not miss it at any cost. Attend all the classes, listen to variety of the models. With anything on which you invest time, you will be extremely comfortable. Everybody kindly reply if this idea is clear. Idea is clear? Right? I am not well, so my voice will be little low, but I am pushing myself to take more and more classes for you. Everybody kindly reply if it is clear to you. So even if the question is r is a rational number, that also we can solve it easily. Right? Pranav, again I am repeating it. 1 to 20, ABC are in geometric progression. If ABC are in geometric progression, B square equivalent to A into C. The entire root cause of the problem is B square is a perfect square, Pranav. B square is a perfect square. What are all the perfect square till 20? 1, 4, 9 and 16. These are the perfect squares. B square, if it is 1, A less than 1, A not possible in a natural number. So what I did is, B square is 4. If B square is 4, B value will be 2. A can be 1. 1, 2, 4. Like that it can go up to 5, 10, 20. Am I right? So total 5 triplets directly I wrote. Next is 9, next is 16. 20 by 4, 20 by 9 and 20 by 16. I hope Pranav you got an idea. Hey Anil sir, then what if it is a rational number? Case number 2. Case number 2. R is a rational number. R is a rational number. If R is a rational number means it is a combination of integer plus fractions. It is a combination of integer plus fractions. Now integer already, let us take the question of 1, 2, 3 till 20. 1, 2, 3 till 20. A less than B less than C, such that ABC are in geometric progression. Such that ABC are in geometric progression. Now see here. Integer, how much we got the answer? Integer we got 20 by 4 as 5, 20 by 9 as 2, 20 by 16 as 1, 5 plus 2 plus, right. Let me use my thumb. A, B, C are in geometric progression. A less than B less than C. What I asked you to take is A value 4. This is nothing but 6, 9. 4, 6, 9 is one triplet that will satisfy. 4, 6, 9 will satisfy. Sir, how can I get these triplet easily? Now see here. 4 is nothing but 2 into 2. After 2, what is the next natural number that is co-prime with 2, which is 3. So write down into 3. Easily you will get the answer. 4 and 6, 36 by 4 it is 9. So next one will be 9. Again I am telling you, suppose if it is 4, 6, 9. How I got this? 4 is nothing but 2 into 2, 4. After 2, what is co-prime with 2? 3. So write down 2 into 3. 2 values you got, third one will be obtained very, very easily. If you want the next value, it is 2 2s are 4. After 2, what is the next co-prime with 2? 3 it is not, 3 we have taken. 4 and 2 are not co-prime. Next it is nothing but 2 into 5. 4 and 10, 100 by 4, it is nothing but 25. See here, R is again a fraction. 4, 10, 25. R is nothing but 2.5. Are you all with me? Still, in any way, this case is not possible because the upper limit is 20. In case if you want one more, 2 into 2, it is 4. After 2, what is the next co-prime with 2? 3 over, 5 over, 6 cannot be possible, 7. 2 7s are 14. 14, 196 by 40. These are nothing but 49. Like that, you can get all the possible triplets. Now, I will solve the question. These are nothing but, instead of counting, directly you can deduce it. 1, 2, 3 till 20. R is nothing but a rational number. If R is a rational number, it should be integer plus fractions. Integer, already we got the answer as 20 by 4, 5, 20 by 9, 2, 20 by 16, 1, which is nothing but 8 we got the answer. Suppose I want in fractions. So fractions, what we will do? A, B, C. First take the perfect square greater than 1. 4 I will do. 2 2s are 4. 2 2 3s are 6. 36 by 4, 9. Otherwise, lot of computation is required. 4, 6, 9. It is derived triplet, which is 8, 12, 18. 8, 12, 18. Next one, it is 4. 2 3s are over. 2 5s are 10. 100 by 4 is 25. It is also giving R value fraction. This case is not possible. So, it is over. Next one, 9. 3 3s are 9. After 3, what is co-prime with 3? So, 4. 3 and 4 are co-prime, 12. 144 by 9, which is nothing but 16. Derived will be 18, 24, 32. These also not possible. These also not possible. So, totally how many you will get where R value is a fraction? 1, 2 and 3. 1, 2 and 3. Answer, it is nothing but if R is a rational number, 5 plus 2 plus 1 plus 3. 5 plus 2 plus 1 plus 3. Answer is nothing but 11. Answer is nothing but 11. This idea of writing the co-primes is extremely important. Otherwise, it will be very time consuming, sir. Think logically. A value if it is 1. B if I take 2 or 3. Everything the ratio will be an integer. So, this case not possible. If A value is 2, B value is 3. 3 by 2 is 1.5. C will be in decimal, not possible. If B is a multiple of A, 4, this is nothing but a derived triplet. It is not possible. A value 3. If it is 4, 4 by 3 is 1.33. I will get a recurring decimal, not possible. After eliminating all these non-possible cases only, I deduced that the lowest value A can take is nothing but the perfect square. Lowest value it can take is nothing but the perfect square. One more question which we will solve. These nothing but the 1, 2, 3, it is nothing but 30. From the first 30 natural numbers, how many triplets? A, B, C. A less than B less than C can be chosen such that they are in geometric progression where R is in fractions. R is in fractions. Directly tell me the answer. Or you take it as R is in rational number. R is a rational number which is fractions plus integers. If R is a rational number, what will be the answer? First case will be integers anyway you can do it. 30 by 4, 30 by 9, 30 by 16, 30 by 25. All these you can do it. Right? Now see here. A is 4. 2 2s are 4. 2 3s are 6. So, it is 4, 6, 9. It is 30. That means 3 more multiples can go. Into 3 it can go. Next one. 2 2s are 4. Next 2 3 over 5. 100 by 4, which is nothing but 25. These over. Next one. It is 4. 2 2s are 2 7s are 14, which is 49. This case is not possible. Next is 3 3s are 9, 3. Next is 3 4s are 12. 144 by 9, 16. This case is possible. Next one, 3 3s are 9. 3 5s are 15. 225 by 9, 25. This case is possible. I hope you are all there with me. Next one. 3 3s are 9, 3 7s are 21, 441 by 9, 49. This case is not possible. So, next case is 16, 4 4s are 4 5s are 400 by 16, 25. This case is possible. Next is 4 4s are after 4. What is co-prime with 4? 5 over. Next is 7. 4 7s are 28. These exceeding the case. So what will be the answer here? Here I got 7. Here 3. Here 1. Here 1. Total here I got 12. Here I got 3 cases. 4, 5, 6, 7. Here 7. So total 19 cases I got. Is the logic clear? Kindly reply in the live chat in case you got any doubts. In case you got any doubts, please write down one point. For R to be fraction, A should be a perfect square. A should be a perfect square. A should be a perfect square, which is nothing but K1 into K1. Right? Take the co-prime numbers greater than K1. Take the co-prime numbers greater than K1. Please write down this point. Everybody kindly reply if this idea it is clear to you. For R to be a fraction, A should be a perfect square. Take the co-prime numbers greater than K1. Take the co-prime numbers greater than K1. 4 is 2 into 2. After 2, what is the co-prime? 3. Right? After 3 into 3, what is the next co-prime? 4. Everybody kindly reply, sir. Everybody kindly reply if this logic is clear to you. If this logic is clear to you, kindly reply. Everybody. Idea is clear, right? Idea it is clear. AP we did it and we will do one good question we will do, then we will sign off. How many factors for 2520 has exactly 4 factors. Has exactly 4 factors. Very good question, sir. How many factors for 2520 has exactly 4 factors? 2520 it is nothing but, let us factorize it. 2 into 1260, 2 into 630, 2 into 315, 3 into 105, 3 into 35, 5 into 7. So these are nothing but 2520 is given by 2 cube into 3 square into 5 into 7. 2 cube into 3 square into 5 into 7. 5 into 7. Now listen carefully. You should have a good understanding of factors to solve the function. In this number, there are some factors for this number. How many factors for this number has exactly 4 factors? For a number to have 4 factors, there are 2 cases. Case number 1. Either the number should be of the form P1 power 3 or it can be of the form case 2, or it can be of the form P1 power 1 into P2 power 1. P2 power 1. That is what, because P1 power 3 means P1 power 0 to P1 power 3. 0 to 3, 4 cases. 0 to 1, 2 cases. 0 to 1, 2 cases. P1 power 3, only one case it is there, 2 cube. P1 power 1 into P2 power 1. How many prime bases are there? 4 prime bases are there. In that 4 prime bases, I need to select any 2. 4C2. So I will get total 6 cases. Don't waste your time in writing all these. 2 power 1 into 3 power 1, 2 power 1 into 5 power 1, 2 power 1 into 7 power 1, 3 power 1 into 5 power 1, 3 power 1 into 7 power 1, 5 power 1 into 7 power 1. Like this, don't write it. So total 1 plus 6. Totally, how many factors for this number has exactly 4 factors? 7 cases are there. How many factors? Totally it